If the purpose to which a component is going to be put to is something which needs to be turned, such as a lock nut, or for example a screwdriver handle, a handle for a gauge, it's desirable to have a pattern produced on the outside of the component which will allow your fingers to grip effectively and be able to turn the component, such as this lock nut. The pattern which we normally produce on the outside of such a workpiece is produced using a tool called a knurling tool. The knurling tool is consisted of an arrangement of two hardened steel wheels. These wheels have a serrated pattern cut into them. The lower wheel has serrated pattern cut that way. The upper wheel has a serrated pattern cut that way. When the tool is clamped onto the workpiece and the workpiece is rotated, the two wheels in conjunction with each other produce a diamond-shaped grip pattern, which I'm going to demonstrate how that's done now. The knurling tool needs to be clamped onto the tool post, as with any other lathe tool, clamped firmly. And because the tool is spring-loaded and on a hinge, it allows it to find its own position, so centre height is not critical with this type of tool. The tool then needs to be moved forward so that the upper wheel and the lower wheel are approximately in line with the centre line of the workpiece. Once again, it doesn't have to be exact. Once that's in position, we can move the tool so that it's at the far right hand side of the area which we want to produce the knurled pattern on. And then we tighten the adjusting screw until it's fairly tight on the workpiece. So the two wheels are squeezing against the workpiece. This is not a cutting process, it's an imprinting process. The RPM selected for this process should be a low RPM. I've selected 70 RPM for the purposes of this task. The spindle can be started and the automatic feed then engaged so that it's moving towards the choke. As you can see, the pattern is beginning to form. There's a certain amount of friction generated between the workpiece and the hardened knurl wheels. Friction generates heat, and therefore it's always a good idea to apply a small amount of lubricant. In this case we're using soluble oil, which is a standard coolant for machine working. The feed rate which has been selected for this process is the highest feed rate which is available on the machine, and that is 1 millimeter per revolution, which means the tool is travelling towards the choke at a rate of 1 millimetre per revolution. The reason for this is because the RPM is very low, and if a fine feed was selected, the process would take an extremely long length of time. The tool's almost reached the end of the area where we want to create the knurled pattern. And at that point, let's disengage the feed, stop the spindle, and then examine the pattern which I've created. The pattern looks good, but it's not quite as deep as I would like. In other words, the diamond pattern hasn't fully formed. When you're doing the knurling process, it's very important that the knurl tool stays in contact with the workpiece from start to finish. In other words, the knurl shouldn't be removed from the workpiece in the middle of the operation. What I'm going to do now is tighten the grip of the knurl wheels a little further. Start the spindle. This time I'm going to start the spindle in reverse direction. This means that when I engage the feed, the tool will move away from the chuck. Once again, we can apply a small amount of coolant . Once the tool reaches the point where we first began, I'll disengage the feed and stop the spindle. We can then see that the knurled pattern has been completed. The tool can be removed from the workpiece by slackening the adjusting screw and then retracted. The process is now complete. This is one of the only times under normal circumstances where the lathe is used in a reverse direction, counterclockwise.